Yes, dear children. Now let us see these point defects. Okay, I have already told you it is of three types: stoichiometric defects, then non-stoichiometric defects, and impurity defects. Right? Now let us see the first category, that is vacancy defect. Now what happens in vacancy defect? See, this is a lattice site. These are atoms, and you find there is some vacant spaces. Okay, so when some of the lattice sites are vacant, then the crystal is said to be having vacancy defect. Okay, now because of this, what happens? Because these atoms which were supposed to be there are not there and they are lying vacant. That means the mass corresponding to these atoms, that is decreasing in the crystal lattice, right? But the volume remains the same, right? So density decreases. Okay, now this particular defect, it can develop whenever heat is absorbed by the substance. So you call this vacancy defect and interstitial defect also as thermodynamic defects. Thermodynamic defects or intrinsic defects. Intrinsic or thermodynamic defects you call it. Okay, so this is about vacancy defect. Now in an interstitial defect, what happens? The constituent particles, if they occupy an interstitial site, then it is called as an interstitial defect. Now what is meant by interstitial site? Now this interstitial site, say for example, look here. There is an atom here, there is an atom here. This is the crystal lattice. Now atoms are all present and there is something more which is other than the host atom, is it not? So some extra constituent particles, they occupy the interstitial sites. Now this is an extra atom. So what it is going to create? It is going to create increase in mass. So when the mass increases, what happens? Density will also increase because density is equal to mass upon volume. So when extra atoms are there, corresponding to that, mass will also increase. So density will increase. So this defect results in increase in density of the substance because volume remains the same, right? Only the extra atoms are present in the interstitial sites. Interstitial sites का मतलब क्या है? Say voids. Okay, the empty spaces between, after the packing of atoms, the empty spaces that is left behind, they are nothing but voids, is it not? So in these voids, if extra atoms, some impurity atom is coming and accommodating, then it will result in interstitial defect. Okay, now this vacancy defect, this is vacancy defect where you find vacant sites, and this is interstitial defect where some extra constituent particles, extra atoms are present in the interstitial site. Now this is in non-ionic solid. Now in ionic solids, what you call them as Schottky defect and Wrinkle defect. Now what is Schottky defect, you see? Now what you find here in this crystal lattice, this is made up of A plus and B minus. Okay, so A plus B minus, A plus B minus, like that it is regularly arranged. Now suddenly you find here A plus was supposed to be there, it is not there, and B minus was supposed to be there, it is not there. So this Schottky defect arises due to missing cation and anion from the lattice site. Due to some reason, this A plus and B minus, it goes out of the lattice. Is that clear? Now, the beauty here is the number of positive charges moving from the lattice side will be equal to the number of negative charges leaving from the lattice side. So because of that, what happens? The electrical neutrality of the solid lattice is maintained. Okay, one A plus is gone and one B minus is gone. So the system or the crystal lattice will remain electrically neutral. Okay, so what is it due to? This is due to missing ions, both cation and anion of equal charge, moving from the lattice site. Okay, that is called as Schottky defect. Now, what kind of compounds exhibit Schottky defect? Those compounds which have a high coordination number. Say, for example, in NaCl. In NaCl, what is the coordination number I have told? It is 6:6. Each Na plus surrounded by 6 Cl minus and each Cl minus surrounded by 6 Na plus. So, in compounds having high coordination number, this Schottky defect has been frequently found. Not only NaCl, you can also give the example of CaCl, where the coordination number is 8:8. So this is one reason. This is found in compounds having higher coordination number. Then number 2, where the difference in size between the cation and anion is small. In such compounds, Schottky defect is found. Okay? The difference in size between A plus and B minus should be small. In such cases, it has been found. Now, when these ions are moving from the lattice side, definitely the mass will decrease. Because of this, what will happen? The density of the solid decreases because mass is out, is it not? So, volume is remaining the same. When mass is decreasing, density will also decrease. Right? So, these are the basic points for Schottky defect. Now, what happens in the other kind, that is Wrinkle defect? Now, look here, this is also similar to that of your vacancy defect. Vacancies are created here, is it not? So, in ionic solid, it is called Schottky defect. In a non-ionic solid, it is called as vacancy defect. Now, what happens in Wrinkle defect? ये देखो, Wrinkle defect में क्या हुआ? You find, see, here A plus was supposed to be there, and this A plus, instead of its own place, it is moving into an interstitial site. Okay, that means displacement of a cation or an anion, generally cation, getting removed from its lattice site to an interstitial site. है उसी में, पर अपनी जगह से हिल के interstitial site में जाके accommodate हो गया. Okay, now because of this, what happens? Definitely there will be some disturbance in the arrangement, right? And the mass is remaining the same. There is no difference in mass because A plus is not moving out of the lattice. So density will remain the same. Okay, because mass is same, density will remain the same. Now, what kind of compounds they show? Wrinkle defect. Wrinkle defect is exhibited by compounds having low coordination number. Schottky is shown by compounds having high coordination number. Here it is low coordination number, and the difference in size between A plus and B minus is large. Okay, generally cations are supposed to be smaller. Okay, that's why I told you cations get displaced from its site into the interstitial site, right? So this large difference, cations are smaller, so they have the capacity to get squeezed into the interstitial site. Okay, so Wrinkle defects are found in compounds having low coordination number, where the difference in size between A plus and B minus is large, and generally cations get displaced into an interstitial site, and this has been found in basically silver halides. It is also shown in zinc sulfide. Okay, silver halides, AgCl. Then you have zinc sulfide. In these compounds, Wrinkle defect has been found to be commonly present. Okay. Now, these solids, they conduct electricity to a small extent. Why? Because vacancy is there. Vacancy means there is an emptiness, is it not? Now, this hole or this vacancy, it may be moving through the complete lattice site. That is, the position of vacancy, it may move around the complete lattice site. That is, displacement of A plus into that vacant site, and another vacant site is created. So like that, because of this, because of these vacancies, conduction of electricity can be easily possible. But then, because of the presence of vacancies, the stability of the crystal lattice can also decrease. I am talking about Schottky defect, right? In Wrinkle defect, what happens? What is the disadvantage? Now A plus from this side, it has gone into the interstitial side. Now these two A plus have become close to each other and they are of same charge. So because of similar charges coming closer to each other, this may result in the increase of dielectric constant of the crystal lattice. So that is one disadvantage in the case of Wrinkle defect. Okay. Now basically, if you have to write the difference between Schottky defect and Wrinkle defect, you find here. In the case of Schottky defect, it is due to equal number of cations and anions missing from the lattice side. This I already told you. Yes, missing cations and anions of equal number from the lattice side. And this is due to missing of ions from the lattice side into an interstitial side. So there is no loss of atom as such. Then Schottky defect results in decrease in density of the crystal lattice, and it is found in highly ionic compounds with high coordination number, where the difference in size between the cation and anion is what? The difference is, in the case of Schottky defect, the difference is more. In the case of Schottky defect, the difference is less. In the case of Wrinkle defect, the difference between the size of anion and cation is large. That is why cation is getting into the lattice site, into the interstitial site. Okay. Here the difference is large. Here the difference is small. I'm sorry. Okay. And in the case of Wrinkle defect, there is no effect on density. Density remains the same. And this is found in compounds having low coordination number, in which the difference in size between cation and anion is large. Right?